Hey guys, this is Mr. H. Hey, I am going to do a quick video on simplifying radicals, adding radicals, multiplying radicals. But before I jump in and show you how to use this with the CAS version, which is much better, much easier, I want to show you how we had to do it before. So on the screen, what you see is it is the square root of 98. Now, let me jump over to my iPad and bring the calculator along and show you how we did this. So I'm going to pull up my iPad. Okay, so basically what we used to do is we would just use menu 23 and we would get the prime factors for whatever number that we're trying to simplify. So in this case, I put 98 in, and that's 2 times 7 squared. So what we would do is we would just rewrite this, expand it out. And the whole thing is any pair of numbers that you find, you can pull them out, but it counts as 1. So we would pull out the 7. So this would be 7 square root of 2. Now that's what we had to do before. We would have to prime factorize it and then look for pairs of the numbers. Every pair that we get counts as 1 outside, right? So that's the answer. It's 7 square root of 2. But now what I want to show you is all you have to do now with the CAS version is you just type the square root and it'll simplify it. So this is much simpler. So this would be 7 square root of 2. All right, let me do another one. I'm going to do it the old way again, and then I'm going to do it using the CAS version. So this is the square root of 25. So we would grab the calculator. We would go menu 23. That gives you the factors. This will give us the prime factor. So it's 3 squared times 5. So if I go to my iPad, let me clear this off real quick. It's 45. So what I'm going to have here is it's going to be 3 times 3 times 5. Now, what we're going to do is we're looking for pairs. So we could pull a pair of the 3's out. It would be a 3 out here, 3 square root of 5. Now that's what we would do if we were using the regular TI-NSPIRE. But now that we have the CAS versions, all we have to do is just type in square root of 45 and it'll give us 3 square root of 5. So that's much easier. So I expect our students to do much better now that we're using the CAS version. Now, we can use this version even when it's in press to test. That's the most important thing. Now, so let me jump and go to another part. I want you to see the other thing. Okay, here. So we've got a radical. They want us to simplify this. So we got 2 square root of 160 minus 10, the square root of 10. Now, I'm not going to do the menu 23 method. I just want you guys to see. All you have to do now is just type in what you see. So this will be 2 square root of 160 and then minus the square root of 10. And then that'll be 7 square root of 10. So that's what we got here. So it'll simplify the radicals for you. Boom, done. Let's go and look at multiply. Same thing. What is the product of 8 square root of 8 times 5 square root of 24? So again, you would just go. Now you have to know that product means multiply, but other than that, the calculator is going to do the rest. So it's going to be 8 square root of 8 times 5 square root of 24. And then we press enter. And it says 320 square root of 3. So that's what we type in. Boom, done. Yeah, so this is going to be a game changer for us when we are taking the Regents exam for questions that have radicals in it. We don't have to do menu 23. We don't have to combine the like terms and look for the coefficients. We just type in the expression and it'll simplify it for us. Now, I want to do one more thing and then I'm going to, so like this one. So this is the kind of question that you might see on the Regents. It'll say, is this rational, irrational? So it says, find the sum of 2 square root of 9 times plus 2 square root of 16. And they want it simplified. So again, we would just go here. We would go 2 square root of 9. In this case, we're looking for the sum, so it would be plus. It would be 2 square root of 16. And then it says the answer is 14, and that is a rational number because it does not have any decimals. So we would put 14 in here, and then we would say the result is rational because it doesn't have a square root part, and it can be written as a ratio of 2 integers, which is the definition of rational numbers, and it does terminate. All right, so that's what you would do. I want to do another one. Okay, so next question. So here it says find the product of 5 times the square root of 18 times 5 square root of 18. So actually, this is going to be rational as well, but let's just go ahead and do it. 5 square root of 18 times 5 square root of 18, and we get 450. It doesn't have any decimals, so this is the product, and it is a rational number because it can be written as a ratio, and it does terminate. So, boom, that makes it much simpler. Now, last thing I want to cover, I don't have that. Yeah, that's it. Basically, that's it. Definition of rational, irrational. Let me do one more question here. I wanted one that wasn't rational. Here's another rational one, but let's just go ahead and knock this one out. Again, we're doing the sum, 5 square root of 25 plus 5 square root of 16. Since those are both perfect squares, we know that this is going to be a rational number, but let's go ahead and let the calculator help us finish this up. Plus 5 square root of 16, and it says that the result is 35, which we expected. It is a rational number because it can be written as a ratio, and it does terminate. All right, so I just wanted you guys to understand, we have CAS versions of the calculator. So when you're taking this exam, you're going to be able to use this feature. So it should make simplifying radicals much easier. Even when we look at things like looking at the quadratic formula and we have to simplify the radical, this would also help for that. So this is a game changer for us when it comes to the radical part. So if you have any questions, let me know. I'm going to stop and I am going to post this.